One of the most difficult challenges in delivering the better, faster wireless everyone wants is interference. Radios interfere with each other in their own network, and in unlicensed or shared access spectrum, you get interference from radios in other networks too. None of this is good. The team at Tirana has made fundamental advances in tackling both of these problems, opening up whole new possibilities in wireless network design and deployment. We'd like to show you the results we've achieved so you can begin to see how these possibilities could unfold in your own wireless strategy. We'll start with self-interference and a quick introduction to our approach. Tirana radios are actually assemblies of a large number of discrete radio chains. Unlike the massive MIMO concepts being explored in 5G, however, we use a unique distributed massive MIMO architecture. This enables advanced space-time frequency adaptive signal processing algorithms and extremely precise digital beam and null forming, which yield perfect isolation of individual co-channel links from each other both within a sector and across sectors. To demonstrate what we mean by extremely precise, we put 3 sectors of our Absolute Air 2 point-to-multipoint system in the same room, with 9 links all operating in the same 20 MHz channel. Each link comprises 2 spatial streams, so processing for each of these streams needs to cancel out 17 others. The systems are all autonomously leveraging the best multipath routes in the channel that both maximize orthogonality between streams and minimize interference, which enables co-channel operation despite nearly zero physical separation of the endpoints. A single AA2 link with 2 streams at steady 256 QAM modulation will yield full-rate spectral efficiency of 9.7 bits per second per hertz. All 9 links in this example operated concurrently in the same channel with zero degradation, carrying a total of 1.7 gigabits per second of traffic with spectral efficiency of 87 bits per second per hertz, as in precisely 9 times 9.7. Adding more sectors pushes spectral efficiency over 100 bits per second per hertz, our typical performance in outdoor deployments. Developing immunity to interference from other networks is even more challenging, since you typically face larger numbers of very unpredictable interferers. This isn't the right place to talk about the approach behind our Advanced Burst Interference Cancellation, or ABIC technology, so let's go straight to results. To show the full extent of the immunity we've achieved, we start with a pair of AA2 radios that have had their antenna interfaces effectively wired to each other. This configuration allows us to also wire one of those radios to the output of a signal generator, our jammer, so we can hit the radio with any desired level of interference while it is exchanging traffic with the other radio. At the outset, with the jammer at low power, the radios are carrying 188 megabits per second of aggregate traffic with 0 packet errors. Without ABIC operating, a rising level of interference begins to cause packet errors, as with any conventional radio. Turning ABIC on returns SINAR to the level required for full-rate performance and eliminates packet errors. The immunity ABIC provides remains perfect as the jammer signal is raised by 40 dB, at which point it is 20 dB or 100 times stronger than the signal of interest. While our signal generator made it easy to show ABIC canceling a wide range of interfering signal strength, we understand an example of a real-world competing network would probably be helpful validation as well. So we've set that up separately with another pair of AA2 radios exchanging traffic, an off-the-shelf enterprise Wi-Fi access point near one end of the AA2 link fixed to the same 5 GHz channel, and 10 laptops exchanging heavy traffic through the AP. With ABIC off, the Wi-Fi traffic, with signal strength on average about equal to the AA2 signal, but peaking regularly above 10 dB stronger, caused serious disruption to the AA2 link, cutting throughput by about 50%. Turning ABIC on eliminated the problem, as with the previous wired configuration example. Note that this isn't just a cool lab trick. Our ABIC technology has been featured in our commercial AA2 products for a couple of years now. It's been extensively validated by Tier 1 service providers, most of whom we can't name just yet, and is delivering license band reliability in free unlicensed spectrum day in and day out in deployments all over the world. As we suspect you can imagine, the implications of our interference cancellation accomplishments are profound. We'd welcome the opportunity to explore how they could be put to use for you. Thanks for watching, and we'll look forward to hearing from you.